Hi guys, good afternoon. So today we'll be starting with the technical part and we will start with the network components. Okay, and before starting with the network components, the first thing we need to know is about network. So what is a network? Device. Okay. So my thermometer is a device? Yes or no? Thermometer is a device. So can I say device? If you are saying device, you say networking device. Or we use networking device or nodes. Node is a proper term for a networking device. Okay, so you can say interconnection of two or more nodes. Okay, all right. So why do you have a network? Okay, this is from the, just give me one moment. This is from the previous batch. Save it. Why do we require a network? About a network, we have seen that what is a network? The interconnection of two or more nodes. Okay, we can say it is the interconnection of two or more nodes. Now, what is the need of network? What is the need of network? Why do you need a network? Sorry? Communication. And when you say communication, what do you mean? What is communication? Data flow, exchanging information, exchanging data from one system to another system, right? So if I don't have network, can I not share the information? Can I not share the data? Are you sure? Okay. Now data can be anything, right? I have one system, I have another system. And this is my PC1, this is my PC2. In this PC, there is some 100 MB information. There is 100 MB data. They are not in a network. So can I share this data from PC1 to PC2 or not? Hmm? Yes or no? Tell me. Can we share or we cannot share? Like what? Wires? No. I'm not connecting in a network. Without network. We are talking about without network. So can I share this information or not? Hmm? No. Really? Don't you know about pen drives? Pen drive is there. Hard disks are there. Before that, CD, DVD was there. Even before that, floppy disk was there. That means we are able to share the information, right? How come you say no? Hmm? Okay. So let's say I can share, but I need some sort of storage media, correct? So just for an example, I'm considering, let's say you have a pen drive with the help of which you will be sharing the information. Okay. Let's say this is your pen drive. Now, what I'll do, I'll copy this data from here to my pen drive. Then I have to carry this pen drive from one system to another system. And then from this pen drive, I have to copy this data from pen drive to EC2. I was able to share. Okay. So you shared 100 MB information. No problem. How much time it took? First of all, you have to copy from PC1 to pen drive. Then you have to carry the pen drive to the second system. Then from the pen drive, you have to copy it to the second system. Okay. What if, let's say, the size of this pen drive is what? Right now, let's consider 4 GB. How much data you can copy at most? 4 GB. That is the maximum we can copy, although in the real scenarios, it will not be 4 GB, but let's consider it full size. Imagine this time I have to copy 16 GB information. Now what? I get two choices. One is I'll copy 4 GB at a time, go to the second system, copy there. Again, come back, copy 4 GB again, go there, copy 4 GB again. How many times I'll have to repeat the process? 4 times. Did it took time? Right? Yes or no? So first problem without network we were facing was time. It was taking a lot of time. Right now you can consider that, okay, this is these two systems, these are sitting nearby. What if one system is in India and second system is in US and you have to share 100 MB information? Just to copy 100 MB information from one system to another system, you would take a flight. Imagine. And when you take a flight, there will be second factor that will be coming in picture, which is cost. Right? So that means it takes cost also. It will be expensive. One is like if these PCs are far by, they will take a lot of time as well as expenses also. Other than that, okay, what if this 16 GB is a single file? Now you cannot copy in parts. You cannot copy it in parts. So you have to go with a higher version. Maybe you will buy 16 GB or 32 GB. And again, let's say you bought 32 GB and next time you want to copy 64 GB information. You will purchase new one. Next time it was, let's say, 512 GB information. Every time are you going to buy new one? Even if you buy, it will be expensive. Right? Got it? How the time was being a problem and how the cost was being a problem. Next was security. Number 3 was what? Security. So how come security is a problem? How come like data security is a concern when you don't have a network? I copied the information from PC1 to the pen drive. I was taking it. I lost it. I lost the pen drive or the pen drive got corrupted. So again, my data is lost. Is my data secure? No. And what if the person who is carrying this information, okay, let's say there is a person who is carrying this information and he comes to know that this information is very confidential to the organization. This information is very confidential. What is the guarantee the guy will not copy this information somewhere else? He may copy, right? So that means we have problems. And if the guy wants, let's say, okay, this was the guy who did something wrong. Okay, let's say accounts guy and he did something here and there in the finances. Now, this report was going through this pen drive. What is the guarantee he will not modify the report? Correct? So again, data security was a problem as well as reliability of data or data integrity, you can say. Data reliability was a problem. Data integrity was a problem. So we were having the communication, but lots of issues were there. So this is why what happened. We eliminated these things. We don't require anymore. What we did? We just connected a cable. And as soon as we connect these two nodes, they are in a network. Okay. Now, first thing, time. Okay. So let's say you want to visit Let's say you want to search a location in US. How much time does it take right now? For example, I go to Google. Okay. And I search for Eiffel Tower, let's for example. Okay, this is a location in France. So I can just go to maps. Here it is. And I can check out the location. How much time does it take? Within seconds, I'm having communication. Let's say one of your relative is in some foreign country. We are able to have video calls. Do you feel any difference? No. It is live. It is not like, okay, you are speaking, then 10 minutes you have to wait. Such kind of thing happens when you go to the space. You send a signal and you have to wait for the response. Again, you send a signal, again, you have to wait for a response. So we don't have that kind of scenario here. Why? Because of the network, because nobody is carrying that information from one place to another place. This is going through the wires. And the entire world, it is connected with the help of wires only. If you want to know how the entire world is connected, so see here. This is how your entire world is connected. These are optical fiber cables, which are lying in your oceans. Okay. Under the oceans, these are the cables that are connecting the entire world. Okay. And through these cables, light signals are traveling. And what is the speed of light? See, this is how your entire world is connected through the cables. These are all cables that are under the oceans. And this is India. So this is, we are able to surf and have, lag-free video calls, all because of these cables. Clear? So through these cables, light signals are traveling. And what is the speed of light? No idea. Engineers and no idea. Strange. I think first year you studied a lot about, in the physics, it is there. And you might have done some practicals also. Reflection, diffraction. Speed of light is 3 into 10 raised to power 8 meter per second. Sorry, not 18. 10 raised to power 8 meter per second, which is approximately equals to 3 lakh kilometers per second. Okay. That means light can travel in 1 second. How far? 3 lakh kilometers. And what is the circumference of your Earth? Perimeter? Also no idea. It is approximately 40,000 kilometers. Okay. So now you can imagine that in 1 second, how many times your light signal can go around the world? Approximately 7 to 8 times. In 1 second, your light signal can travel throughout the world 7 to 8 times. That's why that fast video calls we are able to have. Okay. Because within seconds, your signal is traveling 7 to 8 times. That means going and coming back, not even 1 second, just a fraction of second. Okay. This is why we don't feel that lag. Clear? So first is what? Speed is increased. Speed of communication is increased. And if speed is increased, that means time is automatically less. Then cost. So here, now doesn't matter. I want to transfer 10 MB, 100 MB, 10 GB or 100 GB will not make a difference. Why? Everything can be transferred through the same wire. Everything can be transferred through the same wire. Okay. So what will happen? That you are not limited to the capacity. In pen drives and flash drives, what was happening that you had to buy new ones. Otherwise, you had to copy multiple times. But those kind of limitations we don't have here. And here the communication will be end to end. That means nobody will be carrying the information from one system to another system. There will be no third party involved. So what will happen? Security will be there. And if your data will not get modified, integrity and reliability is also there. So these are the reasons that you need a NIC. Clear? Online people?
Yes, sir.
All right. Now, in your network, okay, in your network, devices are connected. How those devices will be connected? Okay, let's say if you remember, when we take an internet connection at home, so what will happen? Okay, let me show you. This is internet. This is what? Internet. Now, when you take an internet connection, what happens? The service provider will give you a device. Yesterday, we discussed about this device. What is this device? This will be your router. And there will be a cable coming from the internet side to your router. They will connect a cable to your router, right? And with this router, you are able to connect, few devices. Like, let's say if I want, I can connect a switch. Okay. So a router will connect to switch. Then I can connect all my PCs, laptops, and everything. So this is what I can say. This is my network diagram, which is showing you how the devices are connected. Correct? Now, in real scenarios, what will happen? That your devices, your routers, your switches, these will be mounted in the racks. Okay, one example, one rack is here. These will be mounted in a rack. So how does a rack look like for online people? Let me show you. Take example of this one. This is how a rack will look like. Now looking at this rack, can you tell me that how the devices will be connected? We have no idea. We cannot tell you. Why? Because here these cables, these are so well managed that you will not come to know. Right now here I can say that, okay, switch is connected to PC, switch is connected to PC, router is connected to switch. But looking at this image, I cannot say that, okay, which device is connected to which device. I won't have any idea about it, right? So for this reason, we have a concept to know how the devices are connected. And that concept is known as your topology. That concept is known as what? Topology. What is a topology? As simple as like if you want to simply define it, you can say it is the graphical representation of your network. It is the graphical representation of a network. Or you can say it is your network diagram. It is what? Your network diagram. So a topology will tell you how your network devices are connected to each other. Okay. Topology tells you how the nodes, or you can say how the network devices are connected to each other. Okay. Now there are multiple different types of topologies available. Okay, we have bus topology, we have star topology, mesh topology, ring, tree. Okay, but not all of them are being used right now. Okay, in the networks, we majorly use two topologies. One is the mesh topology, and second one is the star topology. These are the two topologies which are majorly being used in the networks. Okay. So first of all, let's talk about the mesh topology. If you want to define the mesh topology, how will you define it? You can say in mesh topology, all nodes, or you can say in mesh topology, each node is connected to all other nodes. Each node is connected to all the other nodes. Now, what does it mean? Let's say I have 5 PCs. These are 5 PCs I'm taking as an example. Consider this is your PC1. And this one is PC2. And this one is PC3. PC4. And this one is PC5. Now what I say that, okay, each node is connected to all other nodes. So that means PC1 will connect to everybody. PC1 is connected to PC2, connected to PC3, connected to PC4, and also connected to PC5. What about PC2? It is connected to PC1 only, not connected to others. So PC1 will connect to, I'm sorry, PC2 will connect to PC3, PC4, as well as PC5. What about PC3? Connected to 1 and 2. Now it needs to connect to 4 and 5. So connected to 4, connected to 5. Now what about PC4? Connected to 1, 2, and 3, not connected to 5. Connected to 5 also. So now everybody is connected to everyone. You can see PC5 also connected to 1, 2, 3, and 4. Okay. All right. Now, in this topology, what happens? There are certain disadvantages. And before that, let me talk about the advantage, that we have some advantage also. What is the advantage? The advantage is if one of the link goes down, let's say this link between PC1 and PC5 goes down. So still PC1 can communicate with PC5. How? Okay. Why it is via this path? This is strange. This can take this path as well as, if not this, wait a minute, I think some resolution issues there. Visible? So it can communicate via PC3 also, can communicate via. This is something mistake. Okay, just give me one moment. So via this path it can communicate. Okay. Via this path it can communicate. Also via this path. Multiple possibilities are there. Okay, can come here, then to the PC3, then go to multiple possibilities are there. So what will happen? That even if one of the link is down, okay, even if one of the link is down, let's say this one is down, so still we will be able to have a communication. So that means we don't have a single point of failure. Okay, this is the benefit. This is what the benefit we have. So let's talk about it. Let it. First, let's talk about disadvantage. What is the oh, sorry, advantage we are talking? The advantage is no single point of failure. That means if one of the link fails, we will still have the communication. But more than advantage, we have disadvantage. Okay. What is the disadvantage? First of all, number of cables. The number of cables. Right now, I connected how many nodes? I connected how many nodes? 5 only. How many cables I required? So you can see here 4 plus 3 plus 2 plus 1. 10. For connecting 5 nodes, I needed 10 cables. What if I have 6 nodes? Well, double. Try to connect 6 nodes and check how many cables. Do it. Make 6 nodes and try to connect it. And let's see how many cables. Don't try to draw very small. Otherwise, you will have a lot of confusion counting the cables. How many? 36. No. Number of cables will be 15. How? See here. 1, 2, 3, 4, 5, and 6. So how do you count? 1. This is, today my pen is not working properly. Everybody is getting 15 cables?
Yes, sir.
Yes, sir.
And for some. Okay. I think this is the problem. Okay. So number of cables will be what? 15. So one thing you came to know, number of cables is, I just increased one node, and how many cables got increased? This I gave you only for 6 nodes. Imagine I give you for 15 nodes. How will your notebook look like? Right? So first problem is number of cables. And not just number of cables, your network complexity becomes high. Network complexity is high. So right now, might be your rack looks like this. But if you connect the devices, if you start connecting the devices in the mesh topology, how will your network rack look like? Okay. Let me open this image. Then you will have your network racks like this. Because number of cables. Okay. So network complexity is high. Now imagine that in this scenario, one of the cable gets damaged and you have to troubleshoot it. First of all, you have to find out the cable. Okay, so finding out a cable in this kind of scenario, very complicated. Okay. So again, if your network complexity is high, troubleshooting is disaster. Troubleshooting is complex. Is that clear? Okay. How do you know that, okay, how many cables you are going to require? So for that, we have a formula, which is n multiply n minus 1 divided by 2. Okay. This is the formula for number of cables. And in this formula, where n equals to number of nodes. Now count it for 100 cables or 100 nodes. In your company, you have 100 nodes. You want to connect 100 devices. So how many cables you will require? Hmm?
48.
Sorry, online somebody saying something?
48. 46.
46? How can you connect 100 devices with 46 cables? 495 cables. Now you can imagine how your networks will look like, right? So now in companies there can be thousands of system also. So this is not a solution for LAN networks. This is not how we connect the devices in the LAN networks. We don't use it in the LAN. Okay. So in LAN, what do we use? We use a different type of topology, which is our second topology, star topology. Okay. In star topology, what happens? How do you define it? You say all nodes are connected to a central device, like a switch or hub. Okay. So again, if I connect the same 5 devices in the star topology, how they will look like? This is first device, PC1. Then you have PC2 and 3, 4, and 5. And they are connected to a central device. So right now I'll consider it as a switch. This is your PC1, PC2, then we have PC3, PC4, and PC5. And we have a switch. All these nodes, they are connected to this central device. Okay, this is how they will be connected. Now here what will happen, whatever the advantage was there in your mesh topology, that will become the disadvantage. Why? What was the advantage? In your mesh topology, what was the advantage? If a cable fails, we will still have communication. That means we didn't have single point of failure. But here what will happen, that if one of the cable goes down, there is no communication with this guy. That means we do have a single point of failure. Okay. If this device fails, nobody will have any sort of communication. Okay. So the advantage there, it will become disadvantage, and the disadvantage there, that will become the advantage. So here, does the network look complex? No. Do we have to use so many cables? No. Only as many devices you use, that many cables will be there. Okay. So first, if I talk about the advantage, number one, less number of cables. Number two, network complexity. Number three, if network is not complex, troubleshooting is also easy. Okay, these things I'm saying in comparison to your mesh topology. Then if we talk about disadvantage, what it is, we have a single point of failure. This is clear. Online people.
Yes, sir.
All right. Noted. Now let's move on to the next part. Which is about topology. We have done mesh topology, star topology. We have to understand about the communication modes, unicast, multicast, broadcast. These things we have to understand. So what is unicast? Unicast means one-to-one communication you have. Okay. In unicast, what you will have? You'll have one-to-one communication. This is about one-to-one. Okay. Now, one-to-one communication means what? There will be only one sender, one receiver. Okay, so let's say I want to have a communication with my friend. So either I will call him or I'll send him a WhatsApp text. But other than two of us, nobody third person will be getting that information. This is what? One-to-one communication. That means unicast. What is multicast? Now, this time I want to communicate with more than one. I have 500 contacts in my contact book, but out of them, only 5 people are there who are my good friends. And okay, we are planning something, let's say. So what I'll do, if I want to share some information with all 5 of them, then rather than sending individually to 5 people, I can just create a group. And I'll drop the message in the group. What will happen? Everybody who is the member of the group, they will receive the information, but not everybody in my contact list. So that means in multicast, what happens? You communicate with more than one. You communicate with more than one, but you do not communicate with everyone. You communicate with more than one, but you do not communicate with everyone. So how do you say it? You say one to many, but not all. You are communicating with more than one, but you're not communicating with everyone. Is that clear? Okay. Now, same like unicast and multicast, we have broadcast also. We have broadcast. Now, what is broadcast? One to all. We were communicating with one, we were communicating with more than one, and now we will communicate with everyone. Okay. So broadcast will be what? One to all. This is one to all communication. This will be what? Broadcast. Now with broadcast, there is a scenario that sometimes if someone is not willing to receive also, still the broadcast message will be there. Okay, the broadcast message will reach. Okay. For example, let's say a vegetable seller is shouting for selling his vegetables. Now, everybody who is listening to that message is not going to purchase the vegetables, right? But still they will get the message. Still they will get the message. So that is what? Broadcast. Whether it is for you or not for you, you will still get the message. If you are in that particular area. Okay, if you are in that particular area. So this is how a broadcast works. One to all communication. What is anycast then? Now you might have heard of, unicast, multicast, broadcast, but might be anycast is a new thing. So anycast means what? One-to-one communication. Anycast is one-to-one communication. Now you should have a question. What is the difference? Right? That unicast also I said one-to-one and yes. So how? Okay. That is simplex, one way. That is different. Okay, that is a simplex communication, that is different. That will depend, like, whether your network is simplex or whether your communication type is simplex, half duplex, or full duplex. That is a different part. Okay, that has nothing to do with your unicast, multicast, broadcast, and anycast. Okay, when I say one-to-one, so if I'm calling my friend can also talk to me and I can also talk to him. We can have two-way communication. Okay. So then what is the difference? In anycast, what happens? That more than one node share the same address. share the same address. And the masses will be delivered to the nearest node. Now, how it works? Understand this thing. Let's consider this is a society. In this society, there are multiple houses. There are multiple houses. And in this society, you have, let's say, two gates, one on this side, one on this side. Okay. And what these guys did, that they kept the same nameplate for everybody. Same name, same plot number, same house number, everything same. That means same address. Everybody is using the same address. Now let's say this guy, okay, let's say plot number was just 11. Okay, just for an example. Let's say the address was what? And everybody using the same address. Okay. Now this guy here, let's say he ordered something on Amazon. This guy ordered something on Amazon. So what will happen? The delivery guy, if he is coming from this side, he will bring the courier. In the courier, the address will be what? 11, right? He will enter through this side. What will happen? He will check the first house. Why he will go any further? He will deliver it here. If he is coming from this side, he will deliver it here. This is a non-technical example. So you can understand that, okay, how it works. Now this is clear. Okay. Now let's talk about a technical example, that in the real scenarios, how it will work. Everybody knows about Google, right? So let's say you are in India and you want to visit Google. What do you type in the search bar? Google.com. You type the website, google.com. If you are in USA, what you will type? Same. If you are in UK, same. Or talk about YouTube. So everywhere you will type youtube.com or facebook.com. Correct? So do you think there is only one server that is serving the entire world? No. It is not possible for one system to provide service to the entire world. Okay. It is not at all possible to serve that many requests. Okay. So what happens whenever you are accessing from India, you're saying google.com, you are getting connected to Google's India server. You are getting connected to Google India server because you're based on your location. If you are accessing from USA, then you will get connected to Google US. If you are accessing from UK, you will get connected to Google UK. But eventually we type the same thing, right? So this is one concept that is, see, in IP address, we will study about two versions, V4 and V6. Okay, so this is not a feature of V4. This is a feature of what? Your IPv6. That's why you haven't came across this thing. Why? Because whenever we talk about networking, we just talk about IPv4 and that's it. IPv6, it looks a bit complicated, but it is not at all complicated. Okay. Even you'll find it more easier than your V4. Okay. So this is clear. The difference between unicast and anycast is also clear. That in anycast, one-to-one communication is there, but the message will be delivered to the nearest one because more than one is having same address. Clear? Okay. Online people?
Yes, sir.
Yes. Okay, that was a yes. Now let's talk about the next concept, which is about broadcast domain and collision domain. What happened? Any doubt? Only one-way communication that the receiver cannot send the message. That it's okay. In Hindi, you can speak no problem. That is half the place. I'll come to that. Coming, it's coming. Don't worry. So next concept we have is about broadcast domain. Now, just now I talked about broadcast. What is broadcast? One to all. Okay. About broadcast, we saw that broadcast is what? One to all. And what does the word domain means? Domain means network or part of network. Okay. So when I say that, okay, when you use a broadcast message, you are able to have communication with everyone. Correct? But what do you mean by everyone? What do you mean by everyone? Right now, I am using a broadcast message. I am using my sound, which is a broadcast message. So everybody is receiving it, right? Online people, offline people, everybody is getting the message. But are the people outside the classroom getting the message? Outside the meeting, nobody is getting this message. Why? Because there is a certain part, there is a certain area out of which your broadcast message cannot travel. That area is what? Your broadcast domain. So broadcast domain is the part of your network in which your broadcast message is going to travel. It is the part of your network in which your broadcast message will travel. Always remember, a broadcast message will never leave a broadcast domain. Broadcast domain is the boundary in which your broadcast message can travel. Clear? So how do you define broadcast domain? If you want to define broadcast domain, you will say it is a network. It can be entire network also, and it can be a part of network also, or part of network in which the broadcast message can travel. This is clear? Okay. Then another concept we have, collision domain. Now, what is this collision domain? Collision means what? What do you mean by collision? No idea? You don't know collision? Boom. Right? Collision means what? Colliding with each other, right? Interfering each other. So collision domain will remain same, network or part of network. Now earlier the broadcast message were traveling. In collision domain, what? It is the part of network where there is a possibility of collision. Where there is a possibility of collision. For example, this classroom. This classroom is also a collision domain. Why? Right now I am speaking. Everybody is listening. What if everybody will start speaking at the same time? Will you be able to receive my message properly? Why? Because your message and my message will interfere with each other. Message will get corrupted. This is what we call collision. That your message and my message will collide with each other. Okay. So how do you define collision domain? You say collision domain. It is a network or part of network where there is a possibility of collision. Where there is a possibility of collision when two or more nodes are communicating at the same time. So right now, one person, me, I'm speaking. Okay, and we all belong to the same collision domain. Right now, we all are member of what? Same collision domain. So right now, I'm speaking, you guys are listening. Perfect communication. But if more than two people will start speaking at the same time, we will start having collisions. Information will start getting corrupted. Okay. So whenever two or more nodes they try to communicate at the same time, there is a possibility of collision. That is your collision domain. So broadcast domain, collision domain clear? Online people?
Yes, sir.
Okay. Now let's come to the part where we'll talk about the simplex, half duplex, and full duplex. What is simplex? Simplex means only one-way communication. Simplex means what? Only one-way communication. That means there is only one sender, one receiver, and communication direction is only one. That means sender will always send the data, receiver will always receive the information. Example. What is the example? Walkie-talkie, is it? FM radio. Okay. The person sitting in the station is able to deliver the information. You didn't like the song, you didn't like the person, you keep on shouting, your message will never reach. Correct? That is one-way communication. Your TV remotes. What are these? Your remote is able to send a signal to your TV. TV is not able to send anything here. Your keyboard, your mouse. What are these? These are all one-way communications. These are all one-way communications. So example, in your day-to-day life, best you can take is FM radio. Now, with one-way communication, it is not really efficient. Okay, one-way communication is not always the efficient form of communication. So some modification was done and we had half duplex. What is this half duplex? In half duplex, you have two-way communication. You have two-way communication, but only one at a time. That means at a time, only one-way communication. And here you can take example of your walkie-talkie. Here you can take example of the walkie-talkie. That one person speaking, so other person will listen. Then once first person will say over, second person will start speaking. Okay. Then number 3 we have which is full duplex. So full duplex is what? We have two-way communication at all times, or you can say simultaneously. At the same time, we are able to have two-way communication. Okay. Example, like you have normal phone call also, you can take. Your phone call is what? Two-way communication. We are able to listen also, we are able to receive also, we are able to send the information also. Clear? Any doubt? No? No. Online people? No response?
Yeah, okay, sir.
Okay. All right. Okay, so now the next thing we have to talk about is the devices. We have hub, we have switch, and we have router. But before going to these devices, we need to understand about these layers. Okay, so right now I'll not go in very detail because we'll have a dedicated session for it. Okay. So we have something called as OSI model. What is the OSI model? This is full form only. But what it is? Understand the question. What it is? What is OSI model? 7 layers. Then what is protocol? OSI model also set of rule, protocol also set of rule. What is the difference? Why? Why it is a reference model? Hmm? OSI model or any sort of model doesn't matter. They are documents. Okay. Set of documents. And in these documents, your protocols are defined. Okay. In these documents, what is there? Your protocols are there. And what is a protocol? Protocol is set of rules. And what do these rules define? How the network devices will communicate. Okay. They will define what? How the network devices will communicate. The rules for communication. So any model, whether it is OSI or TCP/IP, it doesn't matter. They are just documents in which certain protocols are defined. And these protocols, they are defining that, okay, how the network devices are going to communicate. Now this OSI model, it was developed by the organization. Which organization? No idea? Some organization, ISO. Okay, what
ISO.
is the difference? What is the difference? This is your organization, International Organization for Standardization. This is what? iOS, Apple operating system. This one is Cisco operating system. Cisco has already taken the capital I, so Apple took small I. And oversight is your model. Okay, clear? Okay. So the organization ISO brought up this model in the year 1984. Your OSI was designed in which year? 1984. And with the help of OSI, what was achieved? We achieved standardization in network communication. Now, how it achieved and all those things I will discuss when we are talking about the OSI dedicated. Right now, what we have to understand in the OSI model, how many layers we have? 7 layers we have. What are those? Those are application, presentation, session, transport, network, data link, and physical. Okay. And the numbering of these layers. Okay. The numbering of these layers is from bottom to top. That means, what is my layer 1? Layer 2, layer 3, layer 4, layer 5, 6, and 7. Okay, this is how the numbering of these layers is. Okay. Now, why we are talking about these numbers? Because whenever we will be talking about, hub, router, switch, so we'll say this is layer 1 device, layer 2 device. So you must understand that we are talking about the OSI model layers. Okay. And your hub will be a layer 1 device. That means it will be used as physical layer. Your switch, layer 2. Your router is layer 3 device. This is clear. Then your IP address is a layer 3 address, and MAC address will be layer 2 address. These things are clear? Okay. In the OSI model, we have these top 3 layers, which are known as software layers. Why? Because the task of all these 3 layers will be done by a application software. Okay. Then bottom 3 layers, we have hardware layers. Why? Because we are using physical devices here. And this layer in between, it is known as heart of OSI, the transport layer. Why? because this layer is responsible for end-to-end communication. And also we are using two important protocols for communication at this layer, which are TCP and UDP. Yeah. Okay. Then we have to talk about type of addresses also. A small introduction. What is an address? IP address. What is an address? Identity that is used to identify something. Okay, so here we have two types of address, logical address and physical address. Okay, we have two types of address, logical address and physical address. Now, what is logical address and what is physical address? What is logical address? What is physical address? Hardware. So, what is logical? What is physical? What is logical address? What is physical address?
Yeah. Hello.
Yes, please tell me.
Yeah. Actually, logical address we can only that one is the visible. But physical address we can search also and we can do the search like that.
Your voice is not clear. Can you please speak louder?
Yeah, sir. Actually, logical address is like only visible, but physical address also we can physically touch that one. We can do the task like that. That one is a physical.
Mm. Opposite? It is fixed. Okay, so can we change the physical address or not? Are you sure? Physical address example is what? It's already written. At least you can cheat. MAC address, or you call it as a hardware address, right? So yes, it is correct that logical addresses, these are the addresses which are not fixed. These are the addresses which are not fixed. That means this will change. And physical address, these are the addresses that are fixed. Okay, that means they cannot be changed. Now example, we see that, okay, MAC address, but is it really true that we cannot change the MAC address? What do you think? Expertise is required. Let me show you the expertise. This is my Windows network connection. I'm going to a Wi-Fi and I need expertise to turn this button on. What it says. And what is the hardware address? MAC address. And if I'm saying that, okay, use random hardware address, that means it will use what? Random MAC address. Do I really need expertise? What do you think? Good question. Why it is fixed? And how come we cannot change it? If we can change it, how come we say we cannot change it? Either we are studying wrong or either this thing is fooling us. Anything is possible, right? So see, there are two things. One is the address of your NIC. The MAC address that we talk about is the address that is bound to your NIC. That means your network interface card. If you are using a Wi-Fi, so let's say this is the address of your Wi-Fi. Okay. Now, if you change the Wi-Fi, then only it will change. If you use the same Wi-Fi all the time, it will remain same. Okay. But The one that I'm saying that, okay, this can be changed. This is the one that is for communication. That means when I'm having communication over the network, rather than using my real address, I'm using what? Fake address. So how does it look like? Let's understand it with a non-technical example. You enroll in a university. Okay, this is university 1. You enroll in this university. Okay. In this university, you can be identified with two things. One is your name, and second thing is what? Your enrollment number. Correct? Okay. You completed your study from university 1. Now you are going to university 2. Now you are going to university 2. In this university also, you can be identified with name as well as when you're going from university 1 to university 2, will your name change? Will not change. What about your enrollment number? It will change. So that means there is some entity that depends on the university, because enrollment number is something that the university will assign you. Can the university assign you name? Right? Why the name will not change? Why the name will not change when you go from university 1 to university 2? It is already fixed with you. You are the person, right? So this is your MAC address. Okay, this is your MAC address. This is your IP address. And this university is what? Your network. So that means whenever you go from one network to another network, your IP address will change. Why? Because it depends on the network you are connecting to. But will the device change? Are you going to change? No. So your MAC address will not change. Now let's come to the situation when I say it can be changed. Let's say you don't have a very good record in the university 1. Then what you'll do? Maybe you will go here and you will enroll with a different name. In that case, it can change. So your name is actual name is different, but just for enrollment purpose, so that nobody will come to know your real identity, you will use a different name. That is the concept of random hardware address. That your MAC address, actual MAC address is different, but when you're having communication over the network, you don't want to reveal your identity. And that is where you change it. So when you're using random MAC address, it is not changing your hardware address. Your hardware address is still the same, but just for communication, you are using different. Is it clear? Online people?
Yes, sir.
So logical physical concept is clear. Logical address means IPv4 address. We have two versions, V4 and V6. V4 32-bit, V6 is 128 bits. What about MAC address? 48-bit. MAC address is 48 bits. How do you write the MAC address? Like IP address, you can say 4 octets, dots are there. In IPv6, colons are there. How do you write the MAC address? What is the format for writing MAC address? No idea?
Sorry,
Google.
hexadecimal.
Sorry. Hexadecimal, yes, definitely. Okay. We don't have a fixed format for MAC address. So Google it. What is the format? Okay. And I'll be back in a minute. Meanwhile, you Google how MAC address you can write. What is the way to define a MAC address? Like IPv4 with dots, IPv6 with colons. So how do you write the MAC address? That you have to check. Okay. So see here. If it is Windows operating system, okay, let me first take an example of MAC address. How do you check MAC address in Windows? Hmm? If I have to check MAC address, how will I check? There is a simple command, get MAC. And this will give you the MAC address. So I'm using one MAC address from the device. And I'm saying, see, this is one way to define a MAC address. And it is available in Windows. Another way, instead of this, you will use columns. Okay. This is what you will find in Linux. And another way, you will find a notation with a dot also. This thing mostly you will find in Cisco. Okay, these are few formats that you can define your MAC address or write down your MAC address. Note it down. I think Linux based, you will find column. There also most probably you will find column. Anyone who has joined today only? Online? No one? All right. Noted? Now let's talk about the devices. Now first device is what? Your hub. Hub is a layer 1 device. Layer 1 means your OSI model layer 1. We are talking about physical layer. This is which layer? Physical layer. Okay. Hub is a dumb device. Now, what do you mean by a dumb device? Because your hub cannot store any information. Your hub cannot store any information. Your hub has no idea that, okay, on which port, okay, on which port, what device is connected. Your hub doesn't have any such idea. So what will happen? Whenever this guy, let's say this is PC number 1, 2, 3, 4, and 5. So whenever PC number 1 wants to communicate with PC number 5, so what PC number 1 will do? It will generate a message. In the message, it will say source is number 1 and destination is 5. And then it will deliver the message to the hub. Now hub doesn't know where is 5. So what your hub is going to do, it is going to make a blind guess. It is going to make a blind guess. So it will send it to everyone. It will say that, okay, what I'll do is I'll send it to everybody. Now, whomsoever is the correct person, they will accept it, and other people, they will just discard the message. Okay. So that means this was one-to-one communication. Source was defined, destination was defined. Source was fixed, destination was fixed. But what your hub did? Send to everybody. That means one-to-all communication it did. What is that? Broadcast. And you can say your hub is always broadcasting. Hub is always broadcasting. That means doesn't matter it is a unicast message or broadcast message, hub will always send it to everybody throughout all the ports. Is that clear? Then hub has a single broadcast domain. Now, what does it mean, single broadcast domain? It means okay, single broadcast domain means all these ports of hub, they belong to the same broadcast domain. So what will happen? What is broadcast domain? If there is a broadcast message, if there is a broadcast message, that will travel in the broadcast domain. That means it will go to everybody. So hub was already sending unicast message also as a broadcast. So definitely as a broadcast message, it will send a broadcast only. So single broadcast domain means all these ports of your hub, they belong to the same broadcast domain. So if one person is sending a broadcast, hub will send out all the ports. This is your single broadcast domain feature. Then we have hub has single collision domain also. Now single collision domain, like our classroom, we are what? Okay. If you compare this scenario, single collision domain means all the ports of hub, they belong to the same collision domain. So like we all belong to the same classroom. Now what will happen if one person is speaking, we don't have problem. Hub will send it to everybody and the communication will be there. But at the same time, if this guy also tries to send a message, what will happen? More than one node communicating at the same time, then messages will interfere. That means here collision will happen. What will happen here? Collision will happen. And also hub is what? Half duplex. That means in hub at a time only one-way communication is possible. Okay, because if more than two nodes they try to communicate at the same time, their messages, they will just interfere with each other, they will collide with each other. And due to collision, what will happen? Your entire hub will go down. There will be no communication at all. There will be no communication at all. This is clear about a hub. Okay. Now, next device, let's talk about a switch. Hub is a, switch is a layer 2 device. That means what? Data link layer, which is your data link layer. And your switch is what? Unlike your hub, your switch is a intelligent device. So intelligent device means it can store some information. Your switch has an idea that on which port, what device is connected. Your switch has this information. Okay. So let's consider that this is PC number 1, PC number 2, 3, 4, 5, 6, and 7. And they are having the MAC addresses M1, M2, M3, M4, M5, M6, M7. Okay. So your switch, let's say they are connected on port number 1, 2, 3, 4, 5, 6, and 7. Clear? So your switch will store the information. Okay. In switch, we have something called as MAC address table. Okay. We have MAC address table, or we also call it as a CAM table. So what your switch is going to do in this CAM table, switch will store information about, okay, like on which port, what MAC address is connected. This is the information your switch is going to store. So your switch will store the information like port number 1, M1 is there, port number 2, M2 is there, port number 3, M3, port number 4, M4, port number 5, M5, port number 6, M6, port number 7, M7. Now let's say this guy PC1 wants to communicate with PC7. So this guy will generate a message. In the message, it will say source is M1, destination is M7, and it will send the message to the switch. Switch will check the destination MAC address. What is the destination? On which port it is connected? 7. Forward it here. Unicast communication. is possible. And then when this guy will reply, this guy will also generate a message. It will say source is M7, destination is M1. It will send the message to the switch. Switch will check what is the destination. M1 connected on which port? Port number 1. Forward it here. This is how your unicast communication will be possible. So switch can make forwarding decisions. It can store some information. That's why we say your switch is what? It's an intelligent device. This thing is clear? Okay. Then your switch has a single broadcast domain. Again, single broadcast domain means what? All the ports of your switch, they will belong to the same broadcast domain. Now, if they are in the same broadcast domain, that means if there is one broadcast, it will go to everybody. So if this PC is sending a broadcast message, it will go to everybody. This is your single broadcast domain. But in switch, we do have per port collision domain. In switch, we do have what? Per port collision domain. So per port collision domain means what? Now, in case of hub, what was happening? Single collision domain. That means like right now, I am having communication and you are also having communication. We belong to the same collision domain. So if more than two people will start speaking at the same time, what will happen? Collision will happen. But when you have per port collision domain, that means I have a dedicated channel for communication with individual person. Kind of, you can say I have called everybody personally. Now, if you all speak at the same time, I don't have problem. Why? Because for sending you guys with the information, I have a microphone. For listening to you guys, I will have speaker. And it is separate for every person. So will there be any chance of collision? No. There will be no chance of collision. Okay. So per port collision domain means what? That every port of your switch belongs to a separate collision domain. That means whenever a switch is having communication with this device, okay, so this is one collision domain. This is one collision domain. So that means in one collision domain, there will be separate channel for communication. That means you can say kind of that for every port of your switch, okay, for every port of your switch, there is a separate channel for sending the information. There is a separate channel for receiving the information. Kind of highway it is. Different paths for going, different path for coming. And one for each person. One for each person. So will there be any collision? If there is no other car on the road, only you are there, will there be any accident? No. Same way, here we will not have any collision. Okay. So due to per port collision domain, we are also able to have what? Full duplex communication. Full duplex communication. That means I'm able to send the information as well as receive the information at the same time. Is that clear? Okay. So any doubt? No? Which is also clear? Online people? Guys, clear, right? Okay, like that's a yes. Now we have to discuss about your router. Then we have cables. Cables we'll discuss tomorrow. Okay. Let's discuss about routers. Now router. A router is a layer 3 device. That means which layer? Network layer. It is intelligent device. That means your router can also store the information, and based on that information, your router can also make forwarding decisions. So how your router is making the forwarding decisions and all, so those things will be clear when we are talking about the routing concept. Okay. There you'll come to know that router has something called as routing tables. Okay. Okay, you guys don't have permission. Sorry. Now you guys can unmute. Any doubt you have?
No, sir.
So you'll discuss about When we'll discuss about routing, you will come to know that router creates a table, that is known as routing table. In the routing table, router keeps information about networks, that which network is connected on which port. Okay. So then whenever a device is sending a message, so what your router will do, router will, like switch was checking the destination MAC address. Router will check the destination IP address. Okay. So based on that destination IP address, router will decide that, okay, through which port it has to send the traffic. So router can also make forwarding decision. That's why we call it as a intelligent device. Okay. Then your router has per port broadcast domain. Now, per port broadcast domain means what? Like this example. Here, this router has two ports, one here and one here. These are the two ports. So each port is what? A separate broadcast domain. That means this side there is one broadcast domain and this side there is one broadcast domain. And in a broadcast domain, what happens? If there is a broadcast message, it will travel with everybody. But router will not forward it this side. Why? Because a broadcast message cannot leave a broadcast domain. The router will never forward a broadcast broadcast message from one interface to another interface. So this thing will not be possible. Same way, if there is a broadcast this side, it will go here, here, and here, but it will never come on the other side. This is what is meaning of per port broadcast domain. Then per port collision domain. So in router also, every port has a dedicated channel for transmitting and receiving the information. That means here also we will not have any collision. Okay. And due to the per port collision domain with router also, we are able to have two-way communication simultaneously. And that is the reason your router is also what? Full duplex. That you are able to have two-way communication simultaneously. Now, when I say that, okay, there are no chances of collision. So 100% guarantee not possible. Okay, so rather than saying that there will be no collision, how would you say the chances of collision are negligible? Almost zero. Rather than saying R0, almost zero. Okay, we know, right? Dettol also says what? Killing germs, but 99.9% only. Still 0.1% is there. Correct? Same way. Chances are there. What are the chances? Like due to some electrical failure, mechanical failure, there can be collision. But other than that, by default, there will be no collision. And even if a collision occur, whether it is switch or router, both are full duplex per port collision domain. Okay. So even if there is a collision, so only the dedicated port will go down, not the entire switch. In hub, entire hub will go down. But switch and router, the dedicated port will go down. Okay. And rest of the entire device will be functioning. This is clear? Any doubt? No?
No, sir.
All right. So then today we'll wind up here only. Okay. Because again, I have to prepare for 8 p.m. batch. So cables will start tomorrow. Okay. You can look out cables and cable categories. This is what we'll start with tomorrow. Okay. So today you can go and search about cables. All right then. Oh, let me stop the recording.